Okay. The next thing is, not only you can compare the potential, the EMFs of two batteries, you can compare two resistors as well using a potentiometer. For that, you're going to need a very similar setup. So you have the potentiometer wire here, 1 meter wire, uniform thickness, uniform resistance and everything. Then you have another circuit in which there are two resistors, R1 and R2. Now you want to find the ratio or compare these R1 and R2. The same idea, we're going to connect it. So let's say A, and let's call this point B and this point C. We're going to connect this with a sensitive galvanometer, move it along the length and find the balancing point, right? So when it is balanced, the potential drop across this one is equal to the potential drop across this one. That is, the potential drop across the length L1 of the wire is equal to potential drop across R1. So basically, VR1 equals VL1. Potential drop across R1 equals potential drop across L1. So potential drop across R1 will be the current in this circuit, say I, times R1 equals the potential drop across this one would be the current in this circuit, let's say I dash or I dash times the resistance of the length L1, so IR1 is equal to I dash times resistance of the length L1, could be written as rho L1 over A. Okay. Then I'm going to remove these points. I'm going to connect the galvanometer across B and C and find the new balancing point, and let's say that length is L2. Again, you can write a similar equation, IR2 is equal to, because we're talking about the voltage drop across R2 being equal to the voltage drop of L2, so I dash rho L2 over A. The I and I dash will not change because I, as I argued, will depend on when there's no current between these main and sub circuits, when the galvanometer is showing 0, then the current here will depend on this EMF and this total resistance. Similarly, the current here will depend on this EMF and the total resistance R1 plus R2. As long as they are same, the I and I dash won't change. So we find the ratio, you get R1 over R2, L1 over